Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to go over how to determine the K value, the equilibrium constant, for the following species in water, the carbonate ion. Okay, so let's get into this. Now, the first thing you need to determine is whether or not this is a conjugate acid or conjugate base of a weak acid or base. So you got to figure that out. And the other thing you're going to keep in mind is that the equation that's going to be useful in a lot of these is going to be the following. You have Kw, which is the equilibrium constant for the autoionization of water. This is then going to be equal to the Ka value multiplied by the Kb value, where the Ka and the Kb are the equilibrium constants for the conjugate acid-base pair. So this can't be any random acid and base. They're related to each other insofar as that they are conjugates, right? So here we go to the carbonate ion, and you should notice that this is going to be the conjugate base of a weak acid, and that is the hydrogen carbonate ion, right? So you got HCO3 minus. And so this is a weak acid. This is the conjugate base of this weak acid. And so we can use that to help us determine what the K value, the equilibrium constant, is for the carbonate ion. Okay, so Kw, we should all know, is equal to 1.0 times 10 to the negative 14 at a temperature of 25 degrees Celsius. And we can look up the Ka value for HCO3, the hydrogen carbonate ion. And when we look that up, we get, what do we get? We get a Ka of 4.7. Ka of 4.7 times 10 to the negative 11. Let me double check that. So we have, yes, 4.7 times 10 to the negative 11. Okay, so we have the Ka value. We know our Kw, so then all we have to do is plug everything in. So we get Ka, so that's going to be 4.7 times 10 to the negative 11. Multiply that by Kb, the conjugate base, the equilibrium constant for the conjugate base, which in this case is the carbonate ion. And that's going to be equal to the Kw, 1.0 times 10 to the negative 14. Now all we have to do is solve for Kb by dividing both sides by 4.7 times 10 to the negative 11 here, and 4.7 times 10 to the negative 11 there. So this cancels out, and we get Kb is equal to whatever this comes out to be, and that is 2.13 times 10 to the negative 4, I believe. Yes, negative 4. And that, ladies and gentlemen, is how you find the Kb, or the K value for carbonate ion. I hope this is helpful. If it was helpful, if you enjoyed this video, then please by all means like the video, share the video, hit that like button. Also, do me a favor, subscribe to my channel if you haven't already, and hit that notification bell right up there. When you do that, click all so you'll be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.